For our end of the year APES project, we wanted to test the behavioral studies of pill bugs, isopods, whatever you want to call them. We started with two sides. We made a big terrarium, added some rocks on the bottom for substrate, some soil, and then we put in a divider with 3 small holes in the middle. Now, in this, on one side, we put a banana, and on the other side, we put decaying matter, because online, that's their 2 favorite foods. You'd think the decaying matter would be more popular because, as you know, it says everywhere in all the research that we conducted, pill bugs prefer decaying matter because they can use it for shelter and many other things. However, we found that they actually went towards the bananas, as in our studies, we had 8 pill bugs on the banana side and 2 on the decaying matter side.
Explain what you're doing.
So right now we just took out our experiment, which yesterday was algae and natural strawberries that we found outside. And now since we had 8 pill bugs here, 2 here.
9.
I'm just 9 to 1. I'm sorry. I'm just resetting where the pill bugs are. That way it's balanced and every single experiment is the same. So we're gonna start with 5 to 5 and leave it for about an hour and 45 minutes, and then we'll record. After we realized that the pill bugs were more attracted to odor than shelter, we started to pick fruits and vegetables that had high odor. Right now we're on test 4, and as you can see, we're testing oranges, a fruit with very high odor, versus cantaloupes with less odor. Same color, both fruits. One smells more, one doesn't. Simple as that. Right now, as you can see, we're observing the pill bug's behavior, as this one is attempting to cross towards the cantaloupe, surprisingly. And what we've noticed, actually, is it comes down to a matter of different sizes as well. As of now, this area is filled with the larger pill bugs, and this area is filled with the smaller ones. But, of course, we can't really take anything into consideration without waiting the proper 2 hours to let the pill bugs marinate in the environment, and then we can measure where they go. To start our experiment, of course, we had to get pill bugs. Now, the best way to do that, we figured out after the 2 to 3 days that it took us to collect all these pill bugs, was to go in the shade, moist areas, and undercover. So we found a perfect place. We kept visiting this place for about 3 days, and we caught to about 20 pill bugs. Of course, some of them were different species, and we didn't want our experiment to be foiled because we had different species. So we found the same species and out of the 20, and we got 10 of that same species, which is now showing on the screen. Here we'll walk you through our process and what we did to catch some pill bugs. We scattered all these rocks over here, and then all we really did day by day is we came out, flipped a rock, and if you get lucky, just like we just did today, there's a pill bug right there. Go over here, pop it in the container, very gently, and there it is. Although they do appear to play dead, it's not dead. We figured that out the hard way.
We did extensive research on what pill bugs like to eat. They like to eat a lot of fruit, and in particular, we found that they like strawberries. Not only that, they also like decaying plant matter. So on about the first day we were here, we looked around for some decaying plant matter, and we come over here. There is a bunch of decaying plant matter we used to feed the pill bugs on the first day.
To determine which fruits the pill bugs were interested in, we ran numerous experiments involving fruits, using apples, pineapples, cantaloupes, and wild strawberries. And we found that the 2 main factors that pill bugs that impact their interactions with the fruit are odor and shelter.
A big issue with the container was a couple factors. It wasn't big enough. We didn't have a way to divide the pill bugs, and we didn't really know what to do with the container. So as you can see on screen right now, we started with a small little jar, and that didn't really have much in it. We just chucked in some soil, and the first pill bug that we found, which we called Biggie, you can see him right here. He's still with us a couple weeks later. But we started to do extensive research on the behavioral habits of pill bugs, and we realized that layering the substrate would be the most efficient for their habitat. So we found a plethora of rocks to layer on the bottom, and then we found more permeable substance like sand and silt, and then we found a more dense, nutrient-rich soil for the topsoil. Once we found that, our main issue from there was we didn't have a way to divide the pill bugs, because if you just have pill bugs here, food here, when we open the container, they might just run around, and then our data is kind of not really viable. So our first thought process was building a wall, but what are they gonna do to get in between the wall? So we designed a nice little border for the pill bugs with these little holes. So to really cross, they have to put in the effort to climb up and get through. As you can see, this one is crossing towards the oranges right now, which is our current test, orange versus cantaloupes. As of now, we're about half an hour in, and you can see this is kind of what we do in our experiments. There's one pill bug right there, and you can see there's one under the soil right there. He's a little bit below, but you can see him right there. I'm not sure, but he's right there. And then we have a lot of ones over here, so we'll come back in an hour and a half to record the data, and we'll see if it's any different. We'll see if they move around, but this is our container, and this is how we built it. For our first experiment, we used a banana and powdered pill bug food. On one side of the container, we put half of a banana, and on the other side, we sprinkled about 3 grams of powdered pill bug food. We put equal amounts of water, equal amounts of space, equal amounts of light on both sides to make sure that the data wasn't skewed. What we found, as you can see in the chart right here, we had 8 pill bugs on the banana side and 2 pill bugs on the powdered pill bug food side. Now this was interesting because the powdered pill bug food was designed specifically for the pill bugs, and the banana was designed for Nico's lunch. We decided to use our first experiment to help run the rest of our experiments and to influence what fruits we kept in the rest of the container.
For our second experiment, we did apple on one side and decomposing matter on the other. We found that the apple had 7 pill bugs on one side and decomposing matter had 3. We found this interesting because decomposing matter provides shelter for the pill bugs, and it's also everywhere outside in their habitat where they live. Yeah.
For our third experiment, we wanted to solidify the hypothesis that the pill bugs actually wouldn't prefer the decomposing matter and they would prefer the fruit that we put in. So for our third experiment, we used wild strawberries and decaying algae. On the side with the wild strawberries, there were 9 pill bugs found after the time limit, and on the side with the decaying algae, there was only 1 lone pill bug.
So for our fourth test, we did 2 fruits, cantaloupe and orange. We found that the orange had 8 pill bugs on that side and cantaloupe had 2 pill bugs on that side. Yep.
Out of all the experiments, we found that 3 fruits had the most amount. We found that bananas had 8 pill bugs on its side, oranges similarly had 8 pill bugs, and wild strawberries had 9 pill bugs. Although because the wild strawberries was compared to algae, something that pill bugs aren't commonly used to, we didn't want to use that for our final experiment. Instead, we took the banana and the oranges because there were 8 pill bugs in both sides of their experiments. We put an orange on one side and a banana on the other side, and we found that 7 pill bugs went to the orange's side and 3 pill bugs to the banana side. Now, why are all these experiments important? They're all important because the common trend in data that we saw was that the pill bugs would tend to go more to the substance that we put with a stronger odor. In the banana experiment versus powdered pill bug food, bananas significantly had a stronger odor, and we found that they had 6 more pill bugs. In the apple versus decaying matter, the apple had much stronger odor than the decaying leaves, and likewise, it had more pill bugs. Wild strawberries, algae, you can start to see a trend in our data. For our final experiment, we tested orange and banana, and we found that the orange had more pill bugs, and out of all the things we were testing, the orange had the strongest odor to it. Pill bugs use tiny hairs on 2 pairs of their antennas around their mouth and that's how they smell. Online, we found multiple sources saying a good way to scare away pill bugs is by using a garlic spray or anything with a very, very strong deterrent, such as vinegar, garlic, or alkaline. In our test, we tested much more acidic smelling things, such as oranges or other fruits, and we found that the pill bugs actually went towards them, which raises the question, why are pill bugs more attracted to the fruits?
This attraction can be attributed to a combination of factors. Firstly, fruits produce volatile organic compounds, VOCs, that create a distinct aroma. These compounds can act as chemical signals, attracting various organisms, including pill bugs. The scent of ripe or decaying fruits releases these VOCs into the air, which can travel and be detected by pill bugs in their vicinity. Secondly, fruits provide a source of nourishment for pill bugs. Fruits contain sugars and other organic compounds that serve as an energy-rich food source. Pill bugs, being detrivores, are opportunistic feeders that scavenge on decomposing plant material. When they come across fruits, they are drawn to the potential food source and can be attracted by the nutritional value it offers. Lastly, pill bugs are also attracted to the moisture content found in fruits. These crustaceans require a moist environment to survive as they breathe through their gills. Fruits, especially ripe or overripe ones, tend to retain moisture, creating a favorable microhabitat for pill bugs. The combination of moisture, nutrients, and the enticing aroma of fruits makes them an attractive destination for these small arthropods.
Now, why is this important? Pill bugs are a vital decomposer in the environment, and many people use them in their composting bins. As 3 students part of the Wilton, Connecticut community, we want to reduce our carbon footprint, and one thing that we could do to that is start to compost. Although it might be a little bit more difficult for us to be large composters because of our time that we don't really have, one thing that we can do is provide research and data towards pill bugs and their interactive systems. The thing is, pill bugs are large pests in farms and gardens, and if people truly understand the foods that they prefer and the habitat that they prefer, that could prove very vital to reducing pests in their homes and in their gardens.